Catherine deposits 100 into an account at the beginning of each 4-year period for 40 years. The account credits interest at an annual effective interest rate I. The accumulated amount in the account at the end of 40 years is X, which is 5 times the accumulated amount in the account at the end of 20 years. Calculate X. So the first thing to note is that the deposits are happening every 4 years. So that means that in 40 years, there will be 10 deposits. And in 20 years, there will be 5 deposits. And also, because of the 4-year gap between each deposit, we need the 4-year interest rate, the 4-year effective interest rate. And it is denoted by I superscript 1/4. And also, so here we say that the 4-year effective rate, J, equals I superscript 1/4. And since the deposits are happening at the beginning of each 4-year period, so this is annuity due, because in an annuity due, the deposits happen at the beginning of each period. So as we said, that in 20 years, there will be 20 divided by 4 is equal to 5 deposits. And in 40 years, there will be 40 divided by 4 is equal to 10 deposits. And we are given that the accumulated value in 40 years, which would be S10, S double dot 10, because 40 years correspond to 10 deposits. And remember, in SN, the N is the number of payments, so the number of deposits. So we are given that the 40-year accumulated value equals 5 times the 20-year accumulated value. If you go back here, 40 years accumulated value is 5 times the 20-year accumulated value. And so we'll have S10 double dot equals 5, S5 double dot. And now, strictly speaking, remember the S10s and the SN symbol is used only if each deposit is 1. And in this case, since the deposits are all 100, so this should be 100 times S10 equals 5 times 100 times S5. But the hundreds will cancel out, and therefore I've just written S10 is equal to 5 S5. And then from our equation 33.5, the formula for accumulated value equals 1 plus the interest rate power n. And so for S10, it will be 1 plus interest rate power 10 minus 1 divided by interest rate and times 1 plus I, or 1 plus interest rate. In this case, the interest rate we're going to use is the J. And so the first step will be to use this condition to calculate J. So S10, as we spelled out, is this, and then 5 times S5. So S5 will be 1 plus J to the 5 minus 1 over J times 1 plus J. And if you remember, for the annuity immediate, the accumulated value formula would just be 1 plus J to the 5 minus 1 over J. And we said that for annuity due, everything just gets multiplied with 1 plus the interest rate for the corresponding annuity immediate. And in this, 1 plus J factor cancels out from both sides. The J's in the denominator cancel out from both sides. And so we're left with 1 plus J to the 10 minus 1, which is this term, equals 5 times 1 plus J to the 5 minus 1. And to solve this equation, let 1 plus J to the 5 equals Y. So then the other one will become Y squared. So we have y squared minus 1 is equal to 5 times y minus 1. And this one is a difference of 2 squares. So it can be factored as y minus 1, y plus 1. And then y minus 1 can be canceled out from both sides because remember, we have to be a bit careful to cancel out a factor from both sides of an equation where we have to make sure that it's not 0. So y minus 1 equals 0 would imply y equals 1. And so that would mean 1 plus j to the 5 equals 1. That will correspond to j equals 0. And we cannot have an interest rate of 0, obviously, here. Otherwise, we cannot have one accumulated value being different from the other. If the interest rate was 0, then accumulated value would be the same at all times. So we can safely cancel out the y minus 1 from both sides, and we get y plus 1 equals 5, so y equals 4, but y was 1 plus j to the 5. And we now take the fifth. So I've just written this 2 times. Remove it. So 1 plus j would be 4 power 1/5, which is 1.3195, and then j would be 0.3195. And the question was to find x, which is the accumulated amount after 40 years. And that by using 33.5, remember, accumulated value would be each deposit times 1 plus interest rate power number of deposits minus 1. So for 40 years, we figured out that the number of deposits will be 10. Each deposit is 100. Interest rate, we figured out, was 0.3195 for the 4-year period. And times 1 plus the interest rate, and the whole thing simplifies to 6195, which was choice E